All right, Math 2 students, you guys already know how to multiply a binomial times a binomial three different ways. There's the distributive property, there's the FOIL method, and then there's the method where you use a table to organize your answers as you multiply. So a binomial times a binomial would be x plus 1 times x plus 3, and you would use a 2 by 2 table so that you have columns for your x and your plus 1 and rows for your x and your plus 3. So a binomial times a binomial, you use a 2 by 2 table with columns for each term and rows for each term. What we're going to learn today is we're going to learn how to multiply a monomial times a binomial. So if we use 5x times x minus 3, we're going to need a different kind of table, but the problem will work the same way. If we do a monomial times a trinomial, we can still use a table, but the table is not going to be a 2 by 2 table. The table will be a 1 by 3 table. So we have enough room for every one of our terms. And finally, if we're going to multiply a binomial times a trinomial, the best way to do it is by using a table, and it will be a 2 by 3 table. So we're going to start by doing each of these examples using the correct size table so that we can have a spot for every one of our products in the problem. So to begin with, we're going to multiply this monomial and this binomial. Monomial, one term, binomial, two terms. So we're going to have to use a 1 by 2 table. So our table is going to look like this. And we have enough columns to fit in our x minus 3. And we have one row because we only need room for our 5x. So now when I find the product of each pair, 5x and x is 5x squared. And 5x and negative 3 is negative 15x. So on this problem, when we multiply the monomial 5x and the binomial x minus 3, we end up with a second degree binomial 5x squared minus 15x. Okay, on the second example, we have a monomial, one term, multiplied by a trinomial, three terms. So we're going to need a table this time that is a 1 by 3 table. So our table is going to look like this. And we have 3 columns for our trinomial. And we have 1 row for our monomial. And so this is going to be 3x squared times x squared is 3x to the 4th. 3x squared times negative 5x is negative 15x to the 3rd. And 3x squared times 7 is 21x squared. So now our final answer, there are no like terms. So our final answer is 3x to the 4th minus 15x to the 3rd plus 21x squared. Now we're going to multiply a binomial and a trinomial. Binomial, 2 terms. Trinomial, 3 terms. So we're going to have to use a 2 by 3 table to organize our answer. So our table is going to look like this. And we have 3 columns for our trinomial. And we have 2 rows for our x plus 3. And now we're going to get 6 monomials, which we are going to keep organized by using our table. So we have 2x squared times x is 2x to the 3rd. X times x is x squared. Negative 4 times x is negative 4x. 2x squared times 3 is 6x squared. X times 3 is 3x. And negative 4 times 3 is negative 12. So we multiplied a binomial and a trinomial, and now we have 6 monomials one in each box on the table, but I'm noticing that some of those trinomials are like terms. So this has an x to the second, and this has the same variable with the same exponent. This has an x to the first, and this has the same variable with the same exponent. So we can combine these like terms, and we can combine these like terms. So in our final answer, we're not going to have 6 different terms. We're only going to have 4 terms. So we have 2x to the third. That's the first term. When we put these two together, we get plus 7x squared. When we put these two together, we get minus x. And finally, minus 12. All right, one final example. This is just to show you how to multiply a binomial and a trinomial one more time. Everything's going to be a little bigger, so it's easier for you to see on the screen. These are the kind of problems that sometimes people get wrong because there's 6 different terms that you have to sort out at the end, and you got to be very careful about getting all of the exponents done correctly. So we have a binomial here, and we have a trinomial here. So to multiply a binomial and a trinomial, you need a 2 by 3 table. So I'm going to make my table 2 by 3. So I have 3 columns for my trinomial, 2x squared plus 10x minus 5. And I have 2 rows for my binomial, so that's x minus 7. Now I need to fill in these 6 boxes with 6 monomials. So I start out, x times 2x squared is 2x to the third. Make sure you know where that third is coming from. We're adding the exponents. X times 10x is 10x squared. Again, x to the first, we add them and we get x to the second. X times negative 5 is negative 5x. Now for the top row, negative 7 times 2x squared is negative 14x squared. Negative 7 times 10x is negative 70x. And negative 7 times negative 5 is positive 35. So that's the first part of the problem. We found our 6 monomials. Now what we need to do is we need to look carefully to see if there's any of our monomials that have the same variable, in this case x, with the same exponent. And so when we look, I see that I have a negative 14x squared and a positive 10x squared. Those are like terms. I see that I have a negative 70x and a negative 5x. Those are like terms. So these 2 like terms are going to be combined, and these 2 like terms are going to be combined, and that's how we're going to find our final answer. So to begin with, I'm going to write down my 2x to the third. And I'm going to cross this out so I don't forget. And then I have negative 14x squared and positive 10x squared, which is negative 4x squared. And I'm going to cross those out. And then I have negative 70x and negative 5x, which is negative 75x. And finally, plus 35. And that is the answer that you get when you multiply this monomial times this trinomial. It's a polynomial with 4 terms, and it's a 3rd degree polynomial. So that's how you can use a table to organize problems, even if it's bigger than a binomial in a binomial. It works for any combination of polynomials. You just have to make sure that you make the table that matches the combination of polynomials that you have.